Hello scholars, and welcome back to the Minecraft world. Today we're going to be talking about the chemistry that we see in Minecraft. So without further ado, let's get right to it. Let's start off with the four states of matter. The first state we have are solids. Now solids, as you can see here, have a very specific shape and a very specific volume, and they will always keep that. So for example, this little stair block will not expand here to make a wider stair block. I'd have to put another stair block in there if I wanted that to happen. Liquids, on the other hand, will take the shape of whatever container that they are placed in. That's why cups don't always have to be the same shape, lucky for us. So for example, if I make this into, say, a sort of backwards L block, I can have that. The water will take that shape. If I make it a rectangle container, they will take that shape as well, or back to the square shape, they will flow into where they need to be. Now, gases, similar to liquids, also take the shape of their container, but they're much less dense and they are very excited. So the particles move much quicker and they fill the whole area, as you can see. Now the next state we have are plasmas. Now plasmas are a little bit hard to find in Minecraft. You'd need to find a lightning bolt strike, which is kind of hard to create. The example I'm going to say, or use in Minecraft rather, are the beacon beams that they make. This is kind of similar to a plasma stream that we can make on Earth. Now, a plasma is just a gas that has been excited so much that the gas starts to give off some of its electrons. And so that mixture of the gas and the electrons, we call that plasma. Now, besides lightning, a good example is the sun. In fact, all stars are not actually balls of gas, they are balls of plasma. They're very excited gas that turns into this fourth state we call plasma. Plasma is actually one of the most common states in the entire world. In the Minecraft world, however, I believe solids or liquids, one of those would definitely have it. Unless you count the air block, in which case maybe air. Anyway, there are ways of going from one state to another, and each of those ways has a name. So, from a solid to a liquid, we call that melting. From a liquid to a solid, we call that freezing. From liquids to gas, we call vaporization. You might also use the term evaporation. It's the same idea. And going from gases to liquids, we call that condensation. Going from a gas to a plasma is called ionization, and going from a plasma back into a gas is called recombination, because the electrons and the atom particles have to recombine to get from the plasma back into the gas. Now you can go straight from a solid into a gas and vice versa, and going from the solid to the gas is called sublimation. A good example of this is dry ice. Dry ice is named that way because it is frozen carbon dioxide that goes straight into a gas and is not wet. It does not leave any wet things behind like normal ice would if you would put it on the counter. Now going from the gas into the solid is called deposition. A good example of this would be frost. When it's very cold outside, the air can freeze straight into frost on your car windshield or on the grass outside. Now you cannot get from plasma except through gas. So there's no way to go from a liquid or a solid into a plasma. You must first become a gas and then go into the plasma. Now, how do you go from one state to another? Oh look, a chicken. The way you do that is by thermal energy and adding energy. So heat flows from hot to cold. So example, this is a very hot cup of coffee or hot tea or hot chocolate or something like that. Or any time your food is too hot, what do? You let it sit out for a little while. But what you're doing, you're not actually letting the cold come into the food, you're letting the heat escape from the food. That's the reason we wear clothes. You don't wear the clothes to keep the cold out, you wear your clothes to keep the heat in. Because on the scale of things, there actually is not a separate cold. Cold is merely not hot. So just as dark is the absence of light, cold is more like the absence of heat. It's the reason that your thermometer only has one scale. It does not go, there's not a hot side and a separate one for cold. It's just one whole scale where the bottom is cold and the top is hot. So going from different states, all I need to do is change the amount of energy that I have. So for example, in Minecraft there are ice blocks, and if I put an ice block next to a heat source, such as a block of lava, I will eventually get the phase change, there we go, from the solid to a liquid. To do that on a larger scale here, let me take this large ice bucket basically and put a lava right in the middle, and as we can see, the ice melts. Right, lava is very hot, it has a lot of extra thermal energy, and so it gives it into the ice blocks, which then change state. They go from the solid to the liquid, and I get water. Now eventually it will melt one next to it and turns into obsidian, and that's just how Minecraft works here. So let's take this idea of solids and phase changes and look on the more microscopic scale, kind of zoom down and see what's going on. And at the smallest scale, everything looks like a bunch of chickens in a pen. And I promise I have a reason for saying that. So this is a solid on the smallest scale. Notice that it's very organized. So I have 9 little pens in this one area, and each of these little pens has 5 chickens inside for a total of 45 chickens. Now the particles are ordered, so 5 chickens here, 5 here, 5 here, etc. There's an order to this structure. There's not a whole lot of kinetic energy. You can see the chickens aren't really moving around that much. They can turn and they can look and they can sort of walk a little bit, but for the most part they don't move. They kind of stay there. This is why we say that the particles in a solid will vibrate, but they don't move, they stay interlocking. Now moving to a liquid, we can see that there is no order to this. There's no order whatsoever. You know, there's not 5 chickens here, 5 chickens here. They're all kind of spread out. And as you can see, what the chickens do is they expand to fill whatever container that they're in. So if I have a different shaped container, like I do over here, with still the same amount of chickens, 45 chickens, they have expanded and they have contracted to fit in this shape. Now they have more kinetic energy, which allows them to move around. As you see, they're not restrained to these little cages anymore. But the outside gate, this outside fence, what it does is it acts as the attraction forces. So the chickens still feel this force keeping them in one location, in one area as it is, but they do not have to stay in one specific area. Now let's talk about gases. So this is actually still a liquid state, and some of you that are clever with Minecraft might realize what I'm about to do. But what I need to do to make this a gas is I need to make sure the particles are not ordered, which right now they're not. But I need to give them more kinetic energy than the bonding forces. So they need to have so much energy that they are able to break free from each other. So I actually have a lever here which will give us a phase change from liquid, which is what they are right now, into gas, which, as you remember, is called either vaporization or perhaps boiling is a word you might heard of. So let's flip that switch now. As we can see, my gas has started to expand. The chickens are starting to leave, and they expand in there as well, and they're moving all the way around. So eventually the chickens will expand to fill the whole hill. As you can see, they're already kind of doing that. Now if I want to get into the 4th state, because why not, let's do that, I need to excite a chicken even more. So let's do that here and see what happens if I excite this chicken. So here we go, very excited chicken, and they will split off, and now I have 2 particles the chickens had. So let's make some more ionized chickens here real quick, just so we fully understand what's going on. We need to be very thorough with this. So there's one, another one, and there's a plasma chicken right now. And the chickens will give off a feather, typically, and a chicken breast, which, again, is going to be our 2 particles. So the chicken is the standard molecule, and the feather becomes the electron in this example. So anyway, I hope you've enjoyed me burning chickens and talking about chemistry in Minecraft. Have a great, fantastic day, and as always, thank you for watching.